Assalamualaikum and greetings to our lecturer, Dr. Sharfa. Our team hereby today is going to present our project for electromagnetic technology with the prime title of the application of Maglev train that is related to electromagnetic field and wave. Our team consists with 5 members, which is me, myself, Anis Syafiqah binti Hashim.
Hi, my name is Muhammad Aziz Firdaus bin Hasnan.
Hi, my name is Ahmad Alif Imran bin Ahmad Iswari.
Hi, my name is Ahmad Faiz bin Hussein.
Hi, my name is Nurhanisa binti Juki.
Without further ado, Miss Hanisa will begin the presentation.
Okay, in our presentation today, we will explain more about Maglev trend from introduction, benefit and advantage, evolution of Maglev, percentage of country that use Maglev, application, and how a Maglev train move. So here is our infographic.
Okay, I will begin my presentation for introduction of Maglev. So Maglev or magnetic levitation is a type of system that used in the rail transportation that use electromagnetic to move by attraction, repulsion. This was made the train levitate and move by using linear motor instead of the normal motor. Then I will proceed to the benefit and advantage of Maglev. So first of all, Maglev is less expensive to operate and maintain. So this is because of absence of rolling friction, means the part do not wear out quickly. Next, the design of Maglev make derailment highly unlikely to happen and can be made more wider than the standard rail car, which provide more comfort for the passenger. Next, Maglev also produce little to no air pollution from no fuel usage in the Maglev. Next, the absence of friction made the train very quiet and reduce the noise pollution. Lastly, Maglev can operate at higher ascending rate, which is 10% compared to the conventional train, which is 4%. Country that use Maglev, basically there is 5 countries that operate Maglev. Firstly is Japan, which is high in percentage, which is 34%, consists of 3 trains, which is first is Chuo Shinkansen, and then Limino, which is urban Maglev, and then SC Maglev. Next is China. So China operate 2 Maglev, which is Shanghai Maglev and Beijing S1 line. For Korea, also operate 2, which is Incheon Airport Maglev and Changsha Maglev. Germany operate 1, which is M-Bahn, and United Kingdom operate 1, also Birmingham Airport Maglev. Next, I will proceed to the energy consumption. So the energy consumption based on conventional basis, which is feet per kilometer. So the estimation based on the specific consumption put peak power consumption instantaneous value of the Chuo Shinkansen at approximately 270,000 kilowatt at service launch at Nagoya and approximately 740,000 kilowatt at service launch to Osaka, as shown in the deliberation by Japan's Transport Policy Council. So from the graph, we know that when the Chuo Shinkansen and the Trans-Rapid Maglev use the top speed, it will consume more energy compared to the standard operating speed, which is 330 km per hour for both Chuo Shinkansen and the Maglev. Compared to the standard, the steel wheel or the traditional train, it consume less energy. Okay, that's all for me. Thank you.
Okay, right now I am going to talk about the evolution of Maglev. So the fundamental ideas of Maglev technology can be traced back to the early 20th century. through the development of electric motor and the research in magnetism. A few scientists even dare to propose a vehicle that could float using a magnet. So in 1934, there was the first concept of magnetic levitating train, and moving on to the 1960s, the idea really began to manifest. At that time, Germany and Japan began researching the potential of maglev. In the 70s and 80s, both countries made a great progress in developing this train. So Germany built and tested a string of prototype maglev system and called their design the Transrapid. Meanwhile, the Japan also tested two series of their own design called the ML500 and later the MLU. So their train were able to succeed 300 mph. Japan continued to develop in its magnetic technology into the 60s and beyond. They tested a new series called the MLX, and in Germany, a commercial Transrapid line connected Berlin and Hamburg was proposed in 1992. However, in the 2000, the government shut down the project. But not all was lost, though the Chinese took notice and to the Germans to build a Transrapid train in Shanghai, which resulted in now only high-speed maglev train in commercial use. It carries passenger a distance of 30 kilometers in 8 minutes. Thus, the China has quickly become a large player in the worldwide maglev market. That's all from me.
Okay, next I will talk about the application of electromagnetic technology in the maglev train. There are mainly two types of technology in the maglev, which the first one is electromagnetic suspension, EMS, and the second one is electrodynamic suspension, EDS. EMS, the train levitates above a steel rail while the electromagnets are attached to the train oriented towards the rail from below. Electromagnet use the feedback control to maintain the constant distance from the train and the track. For EDS, both rail and the train exert magnetic field and the train is levitated by the repulsive force. The repulsive force in the track is created by the induced magnetic field in wires or other conducting strip in the track. Okay. Okay, now the advantage for both type of the technology. For EMS, there's no wheels needed or the secondary propulsion. It has low magnetic field inside and outside of the vehicle. For EDS, it is heavy load capacity. It also can reach high speed, which is about 500 kilometers per hour.
Next is my part is which is the how a maglev train move. I will start with levitation. With levitation, a superconducting magnet suspend a trail car above a U-shaped concrete guideway, and the magnet repels one another when a matching poles face each other. The magnets employed are superconducting, and they are cooled less than 32 degrees Celsius below zero, it can generate magnetic field 10 times stronger than any ordinary magnets.
And next, propulsion. What is propulsion? Propulsion is the force that guides the train to move forward. To achieve that, Maglev use an electric linear motor. A normal electrorotary motor uses magnetism to create torque and spin an axle. It has a stationary piece, the stator, which surrounds a rotating piece, the rotor. The stator is used to generate a rotating magnetic field. This field induces a rotational force on the rotor, which causes it to spin. The stator is laid flat, and the rotor rests above it. Instead of a rotating magnetic field, the stator generates a field that travels down its line. Similarly, instead of a rotating force, the rotor experiences a linear force that pulls it down the stator. Thus, An electric linear motor directly produces motion in a straight line. However, this motor can only produce a force while the rotor is above the stator. As the rotor has reached the end, it stops moving. As the current direction shifts back and forth in the propulsion coils in the guideway walls, the knot and circle repeatedly reverse, propelling the train by alternating direction and repulsion forces. Okay, and that's all from us. Thank you.